Welcome to Uncle Matt Online Academy. Today we want to continue with our discussion on variation. In our previous lesson, we talked about direct and indirect variations, and we noticed that in direct and indirect variations, one variable or one quantity varies with another quantity. That is, we just have only two quantities varying. We can have A varying with B, or C varying with D, maybe directly or indirectly. In joint variation, it is a type of variation where we have a combination of both direct and indirect variation, or different direct variations or different inverse variations. So when we have a combination of two or more direct variation, or two or more inverse variation, or two or more quantities that contain some of them or one of them is direct variation while another is indirect variation, we call this joint variation, a mixture of direct and indirect variation. Now let's look at some examples of joint variation. In this example, we have that P varies directly as X and inversely as Y. P varies directly as X and inversely as Y. If when P is equal to 2, X is equal to 3, and Y is equal to 4. Now full stop. Question number 1. Find the relationship between the variables, or find the equation connecting the variables. Now 2. Calculate Y when A is equal to 3 and calculate Y when A is equal to 3 and X and x is equal to 4. Okay, now if you look at this question very well, you will see that it contains both direct and indirect variation. That is not the major concepts or the major thing that joint variation is talking about actually. It is not whether it contains both of them. It can contain all the variables, all can be direct variation or inverse variation, or it can be direct and indirect variation mixed. But the major concept here in joint variation is that one quantity is varying with two or more other quantities or two or more other variables. When we talked about direct variation, we consider the situation where one variable varies with another variable, or one quantity varies with another, just one variable. We talk about A varies with B, or C varies with D, or X varies with Y. Now, but in this joint variation, we have one quantity varying with two other variables. We have A, and the A is varying with X and Y. If it is in direct variation, it will either vary with X alone or with Y alone. But in joint variation, it is varying with two or more variables. Like in this one, we have only two variables that it is varying with. So here to state it, we say that A varies with X. This is direct variation. And then the same A varies indirectly with Y. A varies directly with X, and A varies indirectly with or inversely with Y. Now to connect this thing, we can also state it this way. Instead of separating the variation, the variables, we can also say that A varies directly with X, and in the same line, we also say that it varies inversely with Y. If it is varying inversely, we have to write 1 over. So 1 over Y. Now, the next thing, just like we did in direct and indirect variation, is to introduce a constant. To introduce a constant, we put an equality sign and remove the signs of proportionality. We are going to introduce just one constant to remove these signs of proportionality. So we say that A, we now put equality sign, is equal to, we can call our constant anything. Let's call it K. Now, let's put the variables in brackets. X. Then we have 1 over X. Let's separate two of them to show that there are two different variables. That is times 1 over Y. So this means that k is equal to, here, this is x over 1. To make two of them fractions, anything standing on its own is that number over 1. So x standing on its own is x over 1. The essence of doing this is just to make two of them fractions. We have a fraction here, so let's have also a fraction in this place. Now we can now multiply the numerators together and the denominators, we can multiply them together. So inside the bracket, we are now going to have x times 1, that is the numerators, and then under we have 1 times y. So we have inside the bracket, we are now going to have that a is equal to, k is still outside the bracket up is x, y is y times 1, which is y. So we have this. Now, k is still k over 1, so everything up times the one up. So we have, this is equal to k times x, which is equal to kx, then the down one is y, kx over y. Now, in the question, we are given that if when p is equal to 2, x is equal to 3, and y is equal to 4, so we put these values given to us. The essence is we are looking for the equation connecting the variables. For us to get the equation connecting the variables, we have to know the value of k, so that this place that we have in this equation, this place that we have a is equal to kx over y. If you are asked to look for the equation connecting the variables or the relationship between the variables, it means that you have to get the value of k and then put the value of k here and then put the variables. You shouldn't leave the variable as a constant or unknown number. You have to find its value and put it. Then these variables should remain unknown. So if you get the value of k as 1 or 2, you put it 2. That means 2 times x then over y. So whatever you have, just put the value of k in that place, and that becomes, you leave every other thing the way they are, and that becomes the equation or the relationship connecting the variables. So to solve the one or equation number A, we have to look for the constants. Now to look for the constants, we come to this place and substitute those false values given to us. The first A, we know the value of A as not A, P. We actually have that P varies as, so we can have, okay, but we have been using A, so we can just change it to A in the equation. So let's say that A varies directly as x and inversely as, so we can also change this one. Sorry for this. Okay, A is equal to this. So we know the first value of A as 2, then the first value of x as 3, and the first value of y as 4. So we put all these first values into this relationship, connecting this relationship here. So put the value of A and put the value of X and put the value of Y, and then we look for the one that is not known, which is K. Then when we get the value of K, we substitute into that same formula, and that will give us the equation connecting the variables. So if we do that, we are now going to have that A is equal to 2, 2 is equal to K times X is equal to 3, and Y is equal to 4. So we have now that 2 times 4 is equal to 3K. And so K is equal to 2 times 4 is 8. 2 times 4 is 8. K is equal to 3K is equal to 8, and K is equal to 8 over 3. K is equal to 8 over 3. Now you have K is equal to 8 over 3. We put this value of K into that equation we have here. We put it into this equation, that is the value of K here, and that will give us the equation connecting the variables. So if we put it, that means that A is equal to K is 8 over 3. It is up as a numerator. Multiply it by X, then divided by Y. Now that will give us A is equal to, how can we transform this? That is up times up. This X here is also equal to X over 1. Anything standing on its own is that number over 1. So we have X times 8 and 1 times 3. So we now have A is equal to 8 times X, which is 8X, over 3 times 1, which is 3. Then this divided by Y. This Y is on its own, so we can still divide it by 1. Or this is equal to this whole thing. This one represents now represents the upper one, that is the numerator. That whole thing represents this. Then remember that this means this up one divided by Y, which is also this divided by Y. So this Y is standing on its own, and we can also write it as Y over 1. Now, whenever you have something like this, if you have A over B divided by C over D, when you have two fractions that are separated by division, you write the first one and then you invert the second one and change the division to multiplication. Now what this means is that this C that is, you leave the first one like this, the way it is, then the second one, the C that is on top, you bring it down, and the D that is down, you bring it up. So by then you have changed this division to multiplication. So what we're now going to do is that This one is now two fractions. This is the first fraction. This is the first fraction, and this is the second fraction. So we do it like the example I just showed. Now, that becomes, we now invert this x and y. It means that we have to bring the 1 up and bring the y down. So it becomes 8x over y will remain the way it is. That is the first fraction. Then the second one, before we do that, we change the division to multiplication. Multiply by, then the 1 is down, so we bring it up. 1 over, okay, this is 8 over 3. This is 8x over 3. So the y that is down, the y that is up here, we bring it down, and the one that is down, we bring it up. So it becomes 1 over y. So this becomes equal to, then we times the ones that are up and the ones that are down. The ones that are up, the numerators are 8x times 1, which is 8x. A is equal to, the one that is up, 8x times 1, 8x. And the one that is down is 3 times y, which is 3y. Okay, so here we have resolved it and put everything in straight line. So this is the equation connecting all the variables. This is the equation connecting the variables. A is equal to 8x over 3y. That is answer to question number A. Then question number B, we are asked to find y. Find y when A is equal to 3 and x is equal to 4. Now, what we are going to do is that we come to this equation connecting the variables, put the ones that we have, and then look for the ones that we don't know. Already we know the value of k, so we just put, if it is x that is given to us to find y, then we put the value of x and then multiply with whatever we have as k, and then we look for the one that we are looking for, which is now y. And if it is y that is given to you, you put it and multiply it by k, and then you look for the one you are looking for, which is the x, depending on what they ask you to look for. So here, in this case, we are looking for y, we know x, and we know a. So we put them in this equation. Now here, in B, we are told that a is equal to 3. So 3 is equal to 8 times x is 4. They say that x is equal to 4. Then we are looking for y, which is 3y, under 3y. Now this means this is x, 3 over 1. We can still leave it. Now this one here is under as a division. If it's coming to this side, to meet this one, it becomes a multiplication. So we have 3 times 3y is equal to 8 times 4. 8 times 4 is 32. Is equal to 32. So we have 3 times 3y is equal to 9y. So 9y is equal to 32. And then our y is equal to 32 over 9, which is equal to 32 over 9 is equal to 3.6. So y is equal to 3.6 when a is equal to 3 and x is equal to 4. That is the final answer. This is the answer to question number B. So this is how to solve joint variation. It can be two direct variations. It can be two inverse variations. It can be inverse variation and direct variation, a combination of the two. And in joint variation, it is not limited to only two quantities. The first quantity is not limited to having only two quantities. It can have more than two quantities. And that is why we say that in joint variation, a given quantity is proportional to two or more other variables. That is the formal statement of joint variation. In joint variation, a given quantity or a given variable is proportional to two or more other variables or other quantities. Now let's look at our assignment. In the assignment, we have that x varies inversely as a and directly as b if if x, a, and b are 1, 2, and 3 respectively. If x, a, and b are 1, 2, and 3 respectively. Question A. Find the relationship between the variables. B. Calculate A when calculate A when x is equal to 5 and B is equal to 9. C. Calculate X when A is equal to 3 and B is equal to 7. So you work on this as your assignment and submit. Thank you.